The topic for Module 13 is about work, power, and energy. So, energy and matter are inseparable. It is difficult to describe one without the other. We are all familiar with energy. Energy comes to us in the form of sunlight. It is in the food that we eat and it sustains life. Energy may be the most familiar concept in science, yet it is one of the most difficult to define. It is the most central concept underlying all sciences. So persons, places, and things have energy, but we observe only the effect of energy when something is happening. Only energy is being transferred from one place to another. We begin our study by observing a related concept, work. Work. So we do work when lifting a load against the Earth's gravity. The heavier the load or the higher we lift it, the more work we do. There are two things enter in every case where work is done. First is the application force, which is the formula is force equals mass times acceleration due to the gravity, and it is 9.8 meter per second squared. And its unit is kilogram meter per seconds or Newton. Second, work enter when the movement of something because of the applied force or distance covered to the direction through which the force acts. So in physics, work is defined as the product of the force applied and the distance through which the object is moved. So the formula of work is work equals force times distance. Work generally falls into two categories. One of these two is the work done against another force, which an archer stretcher her bowstring, she is doing work against the elastic force of the bow. Similarly, when the ram of a pile driver is raised, work is required to raise the RA against the force of gravity. Also, when we do push-ups, we also apply force there. You do work against your weight. You do work for something when you force it to move against the influence of an opposing force, often friction. So the other category of work is work done to change the speed of an object. This kind of work is done in bringing an automobile up to speed or in slowing it down. Like the cars like that or motors. Remember, the unit of measurement for work combine an unit of force, N, with a unit of distance, M. The resulting unit of work is Newton meter, also called joule in honor of James Joule. 1 joule of work is done when a force 1 joule is extended over a distance of 1 meter, as in lifting up a ball over your head. So, sample problem. How much work do you do when you lift a 10 kilogram suitcase 1 meter off the ground? So, the solution, we must first calculate the force that we exert in lifting a suitcase with a mass of 10 kilogram from Newton's second law to lift a 10 kilogram mass against the acceleration to the gravity of 9.8 meter per second squared requires a force given. So the given is first the formula F equals M times J. So the M is 10 kilogram and the gravity is 9.8 meter per second squared. So the force, we're going to times that and or multiply that. Then the equal is 98 kilogram meter per second squared or 98 joule. Then from the equation for work to find its work, the formula is W or work equals force times distance. So as the result of force, it is 98 joule. Then it times 1 meter, the distance. Then if we're going to multiply it, the equal is 98 joule meter. 98 I mean 98 Newton meter or 98 joule. Next is we'll talk about power. So the definition of work says nothing about how long it takes to do the work. When carrying a load up some stairs, you do the same amount of work whether you walk or run up the stairs. So why are you more tired after running upstairs in a few seconds than after walking upstairs in a few minutes? So to understand this difference, we need to talk about how fast the work is done or power. So power is the rate at which work is done. It equals the amount of work done divided by the time interval during which the work is done. Here is the formula of power. So power is equal to work done over or divided by time interval. So here is also the equation. P equals W over T. So a high power engine does work rapidly. An automobile engine that delivers twice the power of another automobile engine does not necessarily produce twice as much work or go twice as fast as the less power engine. Twice the power means the engine can do twice the work in the same amount of time or the same amount of work in half the time. A power engine can get an automobile up to a given speed in a less time than a less powerful engine can. So the unit of power is the joule per second, also known as the watt, in the honor of James Watt. In 18th century developer of the steam engine, 1 watt of power is expended when 1 joule of work is done in 1 second. 1 kilowatt equals to 1000 watts. We customarily rate engines in unit of horsepower and electricity and kilowatts, but either way be used. In the metric system of unit, automobiles are rated kilowatts. 1 horsepower or HP is the same as 0.75 kilowatts. So an engine rate at 134 horsepower is a 100 kilowatt engine. Sample problem in power. So if a man can carry a 500 sacks of rice from the ground floor to the second floor in 5 minutes, how much power does he have? The distance from the ground floor to second floor is 5 meter. So given M is equal to 50 kilogram, T is equal to 5 minutes equals 5 minutes multiplied by 60 seconds over 1 minute equals to 5 multiplied to 60 seconds over 1 is equal to 300 seconds, and all of that is equal to 5 minutes. Here is the solution to get the power or the total power used by the man. So, to solve for power, we must know the work done by the man in carrying the sack of rice from the ground floor to the second floor. So, power is equal to mgdt. Power is equal to 50 kilograms. Then, for gravity is 9.8 meter per seconds, and 5 meter over 300 seconds. And then when we calculate this, it is equal to 8.17 joule per second or watts.